Mathematician food fights. I don't keep a lot of these jokes, but I like this one. All right, so this section we are going to learn a little bit about parabolas. We're going to be, the next three sections are on conics, parabolas, ellipses, and hyperbolas. So this first section is on parabolas. And so let's go ahead and move forward with this. All right, so here's the geometric definition of a parabola. So a parabola is the set of points in the plane that are equidistant from a fixed point F that's called the focus, and a fixed line, which I'm calling L, called the directrix. Now there's a couple things that I wanted to talk about here. I wanted to mention, well, you can see the directrix here. Let me just get a pen. So here you see your directrix, your focus. And I also wanted to mention the focal diameter. We're going to be talking about this distance that goes from here to here. Okay. And the focal diameter, and I'm just going to mention this here, is going to be equal to the absolute value of 4p. Okay. So you can see that if you wanted to know just the distance from here to here, you could just divide that focal diameter in half. Okay. And also keep in mind, if you know the focus, you would know that the directrix is just going to be in the opposite direction as that. So let's just go ahead and move on to our the first examples. So if we're looking here, this is the parabola that has a vertical axis. Okay, so in both of these, you can see your vertical axis is actually at x equals 0 is your vertical axis. So if you have a parabola with the vertical axis, and I'm just going to change my pen color because I don't really care for that red. Okay, the equation of the parabola is going to be x squared is equal to 4py. Okay, now in these examples that I'm doing in here today, the vertex, we're not going to be shifting them. We're just going to have them at 0, 0, so it'll be nice and easy for us. Okay. Now you can see that your focus is going to be at the point, we're going left or right, 0. So the focus is the P, okay? And then the directrix is just going to be y equals the opposite of P, okay? Now notice if your parabola is opening up, like in this in the first graph, P is greater than 0. And if your parabola is opening down, your focus P is less than 0. And I'll show you examples of both of those next. So let's go ahead and just look at those. Okay, so let's find the following for the parabola. And I'll go ahead and try to just sketch a little graph of this at the same time so that we can kind of have a picture of what it looks like. Okay, so maybe I'll do my little sketch down here. And hopefully it's not so horrible that I have to start over. Okay, so we see that x squared equals 32.64y. So you know that this is going to be 32.64 is positive. So you know that this is going to be a parabola that's opening up. Okay, so we know that x squared equals 4py. So that must mean that 4p equals 32.64. Okay, so we can go ahead and solve for p. Just divide both sides by 4. So that must mean that p is equal to, well, 4 times 8 is 32. 4 goes into 6 once, with 2 left over, and 4 goes into 24 6 times. I believe I did that right. Please just go ahead and check the work that I do. 32.64 divided by 4. That's 8.16. Okay. So your focus is going to be at 0. Remember, it's 0p, so that's going to be 8.16. Okay. Now your directrix is going to be, I really want to get a different color here again. Let me go ahead and get blue. So if I was putting my focus on here, I'll just say it's this point here. We would say that that would be the point 8.16. Your directrix is going to be over here, and that's just going to be this line here. And the directrix would be the line y equals, and remember it's going to be the opposite of p. So your directrix would be y equals negative 8.16. Your focal diameter, as I said, is the absolute value of 4p. Okay, because it's a distance there. So we already know what that is. It's just going to be equal to, we already did 4p. 4p was the 32.64. So it's the absolute value of 32.64, which is just 32.64. Your vertex is just right here, which is at 0, 0. And your axis of symmetry, now we can go ahead and let's just go ahead and graph. If you know your focal diameter is 32.64, if we cut that in half, 32.64 divided by 2 is 16.32. So really, this would, if this was opening out, this point here would be 16.32. $8.16. And then on the other side, it would be, and I haven't drawn this exactly to scale. Let me get my eraser just to fix it a little bit. Oh dear. Felt tip pen. Ink color. And then on this other side, it would be negative 16.32, 8.16. Just so you can have an idea of what that looks like. And of course, this is the line y equals negative 8.16. Your axis of symmetry is this line right here. And that's the line x equals 0. Okay? And I'll try to be a little more, I guess I could have moved my graph over a little bit. I had plenty of room. So let's go ahead and try another one. Okay. Now notice on this one, we have x squared equals negative 20.8. Okay. So this is going to be a parabola that's opening down. So we still have x squared equals 4py. So we're going to have x squared my eraser. That's not what I wanted to write. What I wanted to write was that would mean that 4p equals negative 20.8. So divide both sides by 4. So that means p is equal to negative 5.2. So that's where your focus is at negative 5.2. Here's x, here's y. So it will be, your focus will be at left or right 0, down, negative 5.2, which means your directrix will be at y equals the opposite of that, which would be y equals 5.2. So what we'll have is you're down here, let's say this is down 5.2. So your focus here is 0, negative 5.2. And then up here, we have, that's your directrix at y equals 5.2. Your focal diameter is equal to the absolute value of 4p, which would be the absolute value of negative 20.8, which just equals 20.8. Your vertex is still at 0, 0. Your axis of symmetry, well, let's just go ahead and try to, here's your vertex here. It's opening down. Now we know since the focal diameter was 20.8, half of that is 10.4. So this is going to go out to 10.4 on this side, negative 10.4 on this side, which would give me a point here, and it would give me a point here. Your axis of symmetry, once again, is this line right here, which is the line x equals 0. And I think we're set there. All right, so now let's do two examples of a parabola that has a horizontal axis. So this equation, notice the parabola is either opening right or left. If it's opening right, notice your focus P is going to be positive. P is greater than 0. And if it's opening to the left, P will be negative, less than 0. Okay, so if you have a horizontal axis, your equation is going to be y squared equals 4px. Okay. In this case, still, we're going to have our vertices at 0, 0. Your focus is going to be at P0. And your directrix is going to be at x equals the opposite of P. So let's try a couple examples of these. Okay, so we have y squared equals 39.2x. So this is going to be opening to the right since our P is positive. Okay, so if I'm going back once, you'll see P is greater than 0. It's going to be opening to the right. It's like this first example here. So we know that y squared equals 4px. Okay, so 4p equals 39.2. Divide both sides by 4. So p equals 39.2 divided by 4. So just go ahead and quickly do that on your calculator. 39.2 divided by 4. And I get 9.8 as your focus. So let's just go ahead and sketch this. So your focus is going to be at 9.80. Make sure you write that as an ordered pair. So I'll just put the point. I'll just say this is 9.8. 9.80. Okay. So your directrix is going to be the opposite of that. So that's going to be back in this direction. It's going to be that line, which is x equals negative 9.8. Okay, your focal diameter equals the absolute value of 4p, which equals the absolute value of 39.2, which just equals 39.2. And making it easy on you, our vertex is just 0, 0. Your axis of symmetry now, though, is your x-axis instead of your y-axis. So it's going to be y equals 0. Okay, now let's just go ahead and get a sketch of this. So we know if the focal diameter is 39.2, let's divide that by 2. 39.2 divided by 2. So that gives us a point that's up 19.6 and down 19.6. So that would just trying to see if I'm off here a bit. And then we'd have another point that's like right out here. It's going to look something like that. Just a sketch of it anyways. Okay. All right, let's try one more of those. All right, so now we have y squared equals negative 32.4. So this is going to be, once again, your axis of symmetry is still going to be horizontal, but this is going to be opening to the left. Still going to have your vertex at 0, 0. Y squared equals 4px. And we have y squared equals negative 32.4, which means 4p equals negative 32.4. Divide both sides by 4, which means p equals negative 8.1, which puts your focus over here. which is the point negative 8.10. Negative 8.10, which puts your directrix over here. It's going to be that vertical line. X equals the opposite of P, so X equals 8.1. Your focal diameter is equal to the absolute value of 4P, which equals the absolute value of negative 32.4, which just equals 32.4. And if we cut that in half, that's 16.2. So that's going to be up 16.2. And down 16.2. So that would put a point here and here for us to go through. To get a rough sketch of our parabola. And then once again, this is our axis of symmetry right here, which is the line y equals 0. All right, so I've given you an example of each of those, opening up, down, and then opening right and left. And then I just have one application problem here. So I hope you're finding this helpful. All right, so a searchlight has a parabolic reflector that forms a bowl, which is 13 inches wide from rim to rim and 4 inches deep. If the filament of the light bulb is located at the focus, how far from the vertex of the reflector is it? Okay, so I just drew something like this, opening like this, and really that should be the same distance on the bottom. So we'll say that hope you guys are patient with me. There, that's a little bit better. Okay, so 13 inches wide from rim to rim. So that would mean that the distance from here to here is 16 inches. Or I'm sorry, 13 inches. Well, half of 13 is 6.5. Okay, and then also it says it's 4 inches deep. Okay, so that means that this is 4 inches. From here to here is 4 inches. Which means this is 6.5 and this is 6.5. So this point right here would be 6.5. Does that make sense? And then this point, if this was a point, this point would be for negative 6.5. Okay? Now we know that the graph of this parabola would be y squared equals 4px. Okay, so we can use either of those points. I'm going to go ahead and just use this top one, and I'm going to say y squared, which is 6.5 squared equals 4. And we're trying to find p. We're trying to find the focus. That's what we're trying to find, is if the filament of the light bulb is located at the focus, how far from the vertex of the reflector is it? Okay, so we are trying to find the focus, which is P, which is what we're trying to find. So that's just going to be 4 times P times X, which is 4. Okay, so we're just going to have 6.5 squared equals 4 times 4 is 16p. We'll divide both sides by 16. So let's just do 6.5 squared. 6.5 squared divided by 16. And I get p equals 2.640625 inches. So that's how you tackle that kind of problem. And I would just go ahead, I wouldn't round it. I mean, you can try rounding it and see if it accepts it, but I would just stick in the entire number that you get. Okay, so that's where the focus would be located. So that would be, I don't know, just about kind of like right in here or something, or maybe a little farther along because it's closer to 3, so a little farther than 2.5. Okay? Alrighty, so I will go ahead and get this posted now. I hope you are all having a good day.